Hi everyone, welcome back to our Chem Corner. And yeah, today we are continuing our chapter review, the last checklist for your exam. So in today's video, we are going with the kinetics. See, my personal favorite chapter. Why I'm so obsessed with this chapter? The questions are really direct questions, right? Did you feel like that? There is not much complicated things, and there is not much so many different concepts. Not like that, as in acids and base and thermochemistry. So this chapter is very crisp and clear chapter, I think. So if you study this chapter, you can score. You didn't miss any point, due to the complexity, right? So definitely do not miss this chapter. It's very important and neat chapter. Let's get into the video. So let's see the important points in kinetics. First one you need to do with the rate equation, factors affecting rate and rate laws, collision theory, effect of temperature and catalyst, reaction mechanism. These are the important points we need to know with this chapter. And see the weightage, it's same like a 7 to 9 normal percentage. Okay. Then see, first thing, rate equation means, see, suppose this is our equation. How do you write a rate equation? Like, see, the stoichiometric coefficient like A, B, C, D's are there, and A and B is our reactant and C and D are the product. So you can write the rate in terms of everything. For example, we can write the rate expression in terms of reactant. While you're doing with the reactant, you need to write that negative sign, isn't it? Because reactant concentrations are decreased during the time. So 1 over A, the coefficient is there. So what we are doing is average rate. So while you're doing average rate, the coefficient also you need to take care. Okay. Minus 1 over A, D of like change in concentration of A over change in time. Okay. And the same thing you can express in terms of change like concentration of B, like change in concentration of B over change in time. Correct. And similarly you can say the same thing with the concentration of product, like appearing rate, isn't it? Or 1 over C, change in concentration of C over change in time. So this time I didn't take a negative charge because it's reacting, it's producing, right? So products are producing. So 1 over D over the change of D over dt. So like that you can express the rate equation in terms of every reactant and in terms of product. Okay, so you can see this kind of graph because initially this is the reactant and reactant concentration is decreasing during the time. So this will be the concentration of reactant versus time graph. Correct? Okay. And then you can expect like unit of rate is very important. What's the unit of rate? Yes, we are doing a change in concentration over time. So concentration unit is molarity and time unit is second. So molarity per second will be the unit. Okay. This is not rate law constant unit, rate unit. Okay. Then so you can expect these kind of questions. Decomposition of phosphine occurs via the pathway given below. Okay. So see 4 pH3 is reacting and we got only 1 P4 and 6 H2. Okay. So if the rate of disappearance of pH3 is 2.5 times 10 to the power of minus 3 molar per second. Okay. What is the rate of appearance of P4 at the same time? So you can do in simple way, you can just think about, see, when 4 moles is reacting, we got only 1 P4. So if 4 is the disappearance rate, like, sorry, 2.5 times 10 to the power of minus 3 is the disappearance rate, then appearance rate will be 1/4 of that one, right? You can think in logical way in that way, or we can think like equation 4. For example, you can write average rate is equal to, in terms of pH3, you can write minus 1 over 4 change in concentration of pH3 over change in time, which is equal to 1 over 4 change in concentration of P4 over change in time, right? So see here, disappearance rate means disappearance of pH3 means they only include this much. This is what you called disappearance rate. We are without that stoichiometry. Okay, so that is 2.5. So 1 by 4th of 2.5 times 10 to the power of minus 3. So that will be the thing. Okay, it think logically it's also the same thing. Okay, so that's how we need to do this kind of questions. So average rate have to include the stoichiometry. Just disappearance rate or appearance rate, we do not want to include that stoichiometry. Okay, right. Then the next point is factors affecting the rate. This is the core of this chapter. We are dealing with the different factors which affect the rate of reaction. Okay, mainly the concentration of reactant. Only you can talk like a concentration of reactant increases, the rate is also increases, right? But actually rate law will determine what is the exact relationship between this concentration of reactant and the rate. Okay, so what is rate law means? Every reaction there is a particular rate law. So how we are writing the rate law? Rate is equal to a rate constant k and a raised to some power will be there. Suppose see, this is the reaction, a plus 2b plus c will give a d. Okay, what we are going to do? The rate law. So here the reactants are a and b and c. So how this concentration of a, b, c will going to affect the rate? Okay, so can I write like k rate is equal to k a raised to the power 1, b raised to the power 2 and c raised to the power 1? No, the coefficient and the rate law power have no connection, isn't it? So here I am just writing some m n and the c raised to, oh, that will affect maybe, like it's means concept with o, so I'm just giving x y c. Okay, so see, this 2 or this 1, the coefficient, there is no relation with this rate law power. Okay, then how do you get this power? Or what is this power? The sum of the power is what we called order of reaction. So x plus y plus c is what we called order of the total reaction. So this is what we called the rate law. And how do you get this x, y, c? You just think about experimentally. You will get provided with the experimental result. Okay, so look at the experiment. And what you can see here, what you need to do is when you're comparing 1 and 2, experiment 1 and 2, a is the same, right, and b is also the same, but c is doubling. Okay, c is doubling. Okay, then at that time, see, the rate is not that's also not changing. Okay, so c is doubling means just think about the c coefficient. So c doubling means the base is 2 and the power is c is equal to what? The rate is also the same, right? So you can write consider like 1. So 2 raised to c is equal to 1. Then what may be the c value? Yes, it is 0. Anything raised to 0 is 1. In that way, you have to deduce this xyz. Got it? So it's through experimental result only we can assume the XYZ value. We are looking on the stoichiometric coefficient, we didn't get it. Okay, so let's see the A and B. So for getting A concentration, what you need to do? Can we take 2 and experiment 2 and 3? A is same, B is doubling, but C is also changed, so we don't want to take that one. For easy thing, you can do the 3 and 4. Look at 3 and 4. 3 and 4 also, the A is only changing, right? A is doubling. Okay, B is same, C is same. See, the rate is quadruple, right? So at that time you can consider again A is doubling. So 2 is the base and 2 raised to x is equal to, since it's quadrupling, you can write 4. So x will be 2. Okay, then for B coefficient, B power, what's the thing you need to take? 1 and 3 you can take, right? 1 is same and B is doubling, okay, and C is also same, and at that time the rate is doubling. Okay, so B is again doubling, so the base is double, the 2, and 2 raised to y is equal to doubling, so 2. So y is equal to 1. Like that you can get it the rate law. So our rate law will be rate is equal to a raised to k is there, a raised to 2 and b raised to 1 and c raised to 0. So it is overall the third order reaction, a, or you can say second order with respect to a, first order with respect to b, like that, and zeroth order with respect to c. And in this chapter we will study with the whole rate laws, first order and second order. Okay, so see, there are some four main points are there. You need to study with those four main points. So first point, see, first of all, this is the zeroth order rate law, right? I think you can see now. Okay, so see, this is our zeroth order rate law, normal rate law. But there is an integrated rate law. So this is our integrated rate law. It is equal to minus kt plus a0. So according to this integrated rate law, what is the thing? What versus what will be a straight line? Yes, concentration versus time will be a straight line. Okay, AT is equal to minus KT plus A0. So concentration versus time will be a straight line. And see the half-life equation, T half is proportional with A0. T half is equal to A0 over 2K. So T half is proportional with the A0. If A0 is double, T half is also double. That's the meaning. And this thing. And the main thing is unit of K. Unit of K, you can take a general equation, molarity T raised to 1 minus n second inverse. Okay, so n means order of reaction. So if it is 0th order, 1 minus 0, just molarity per second. Okay, so main thing, the unit of, what are the 4 points? First one, a unit of K. And second point, integrated rate law. Third point, the graph, what versus what. A, concentration versus time will give a straight line for 0th order. Okay, and T half, it's related to A0, direct relationship with the A0. So that's the fourth point. Similarly, see the second rate law, like first order thing. First order means rate is equal to K A1, correct? So at that time, see, according to our equation, m raised to 1 minus n. So 1 minus 1, 0. So second inverse. Second inverse is only the unit of K. And this time, instead of 80, you have to consider ln 80, and minus kt, there is no change, and ln a0 will be there. The equations are provided, no issue. But what versus what will be a straight line? Yes, this time ln versus time will be a straight line, and the same negative sloped line. Okay, and the main thing is this one. See, 99 questions of this kinetics chapter, it will be from first order. Like if you want to, like the questions be like, they will give the question and some clues may be there, and the question be like, which is the order. Okay, you have to find out the order of reaction. If they were not given like this kind of, see the this kind of table questions, without this table question, if it's a direct question like some other clues are hiding in the question, then usually that is first order reaction. And the clue is simply, if initial concentration is changed, T half will not change. Okay, so that's the main thing. I will show the questions like this kind of way. Okay, the hiding T half and the, I will show. Okay, and this one is, third one is second order reaction. And see, m raised to, what's our equation? M raised to 1 minus 2 at this time. So it will be minus 1. Molarity raised to minus 1, second inverse. Okay, and see the equation, integrated equation, this time it's 1 over 80 is equal to, instead of minus kt, this time it's plus kt, and 1 over a0. So what versus what will be the straight line? Yes, 1 over a versus time will be the straight line, and see the graph difference, it is positive sloped line this time. Okay, and again T half and a0 is inverse relationship. Okay, that is inverse relationship. So what do you mean by these things? 10 grams to 5 gram means half life, right? So we are starting from 10 gram, and now it is reduced to half, means the time required for that change is T half. So suppose I am telling the T half is 20 minutes. Okay, then I am changing 5 grams to 2.5 gram. So how much time it will take if it were a zeroth order reaction? Zeroth order reaction, it is a direct relationship. Is that the thing we studied? See, direct relationship. So if T initial concentration is halved, the time is also halved. So now it is only will take 10 minutes. Okay, and the same thing, if 5 gram is turning to 2.5, if it were a first order reaction, what happened? How much time it will take? That is the thing we are telling, it's constant. Even you are reduced to half, the A0 is reduced to half, the T half is constant, it will take the same 20 minutes. Okay, and if it is again 5 grams to 2.5, and if it were a second order reaction, what happened? That's why we have studied it is inverse relationship. When you halved the configuration, the T half will be doubled. Okay, so that's why they will take some 40 minutes. Okay, so that is the thing. It will take some 40 minutes. So this is the what, T half and the A0 relationship in various cases. Okay, right. Then the next important point is collision theory. Okay, collision theory, main thing, how the reaction is happening. How the reaction is happening, two things are there. The reactant molecule have to collide in proper orientation and with a threshold energy, like more than the threshold energy, right? So there should be a proper orientation, and the collision can provide an energy greater than activation energy. That threshold energy is called a activation energy, right? Orientation. Okay, right. So this kind of questions you can expect like this one. See the question, reacting with the NO3 gives 2 NO2. So which of the following is most likely to an effective collision? That is the question. So see, NO is turning to NO2. So how do you do this kind of questions? NO plus NO3 gives 2 NO2. So see, nitrogen is this one, the gray colored thing, and the oxygen is plain. So what is the thing is, NO is reacting and NO3 is colliding. So that what you need is NO2. So what is the structure of NO2? Yes, NO2 means this is the structure of NO2. So we need an NO and this kind of structure. Okay, so there should be an attachment with the nitrogen at the center and two oxygen at the terminal position. Okay, so you just tick like that. Okay, so here see the thing, first option, this is oxygen and this is again oxygen. So oxygen oxygen bond is there. That is not the thing. Okay, so here see, this is nitrogen, here is oxygen, and oxygen again this is nitrogen, right? NON, that is also wrong. Okay, here see the heating atom, this is oxygen, this is nitrogen, and again this is nitrogen. Yeah, that's also not be the bond. And what about this one, this is oxygen, this is nitrogen, and the colliding atom is oxygen. Now yes, we need that kind of bond. Okay, so that is what you mean by proper orientation. So you can expect this kind of question. Okay, that's it. Then the thing is effect of temperature. As you know, both endothermic or exothermic reaction, temperature always increase the rate of reaction. Okay, endothermic or exothermic, temperature is always increasing the rate of reaction. Okay, they are operating like more percentage of or more number of molecules having an energy greater than activation energy. That's how they were operating. Okay, so see the curve, you can see the graph. um, yes, now I think you can see it. So here see with the T1 means the blue color area, blue color graph, and see the area under the curve means it's saying like the number of molecules, the total number of molecules. This is the energy line, right? So here after this one, after this area, sorry, after this energy, so this much of molecule is having an energy greater than activation energy. Okay, and at higher temperature, see the area is increased now, which means at higher temperature there is more molecule having an energy greater than activation energy. Okay, there is no change in activation energy. Activation energy is still the same in case of temperature effect. Okay, so this is how the temperature like work. So definitely for endothermic or exothermic, temperature will increase the rate of reaction. Okay, so there is an this is an Arrhenius equation, like think about the x and y axis, that's all, not that much of important. But ln k versus 1 over t, ln k versus 1 over t will give a negative sloped line. Okay, minus EA over R will be the slope of the line, and this intercept will be ln A. So just want to learn about this axis. That's all. Okay, and then we need to study with the effect of catalyst. How catalyst will affecting the rate of reaction. So from this figure you can tell how they were affecting the rate of reaction. Okay, so see, so catalyst how they were doing, they are doing a different pathway, right? They are doing the reaction in a different pathway, alternate pathway. What is the specialty of that alternate pathway? Yes, that pathway having a lower activation energy. Okay, so that the reaction will take part in high speed. Okay, that's, I think it's easily understood. Okay, and the next point we need to do is reaction mechanism. Okay, reaction mechanism is very important. As I told you, while you're writing the rate law, you don't have the permission to write the stoichiometric coefficient as power, right? So here you can't write rate is equal to rate law, like rate is equal to K A square, B square, like that you can't write. Okay, but you can have the right only when the elementary reaction is there. If you have the elementary reaction, you can do like that. Okay, what I mean by elementary reaction? Yes, the step by step reaction. Okay, this is the overall reaction. So overall reaction we can't write, that is wrong. When you write this one, that is wrong. Okay, but you can write this one with the elementary reaction, the step by step. So this overall reaction is happening through this 1 2 3 step. Okay, so here each reaction rate, like each rate law, for example, if you want the rate law for the first reaction, you can write rate is equal to k. This time you can think about the coefficient a raised to 1, a raised to 1, so a raised to square, like that I can write the rate law for the first reaction. Okay, that's I'm telling. Okay, and the second reaction also you can do the same thing. So for the elementary reaction you can write the rate law, the powers as the stoichiometric coefficient. Okay, then some important points are there if you given with this kind of molecular elementary reaction. Okay, first one, slow step is the rate determining step. So how do you write the rate law for this kind of reaction? You just go with a slow step. First you have to go with a slow step. So this is the second step, is the slow step they were given. So you can write the rate law like rate is equal to x raised to 1 and b raised to 1. So this will be the slow step rate law. Okay, and then if any substitution is possible, you can do the substitution. Substitution is usually possible only with a fast equilibrium step. So in which is the fast equilibrium step? This is fast, but this is the fast equilibrium. Both forward and backward reaction is there. So you can substitute that x is equal to a plus a, which means you can just substitute x like a square. Okay, so the rate law for this whole reaction is this one. Rate is equal to k will be there, k times a square or times a raised to b. Got it? This is how we get this rate law. Okay, from the reaction mechanism. Okay, if it's so, this method, like we are applying the fast equilibrium step, we are substituting. This step is called a SSA, steady state approximation. Okay, and also we can expect some question to be like, what is the molecularity of this reaction? So molecularity of the reaction, like that thing is not there, that is wrong. Molecularity of a particular reaction you can say, like particular step. For example, step 1, what is the molecularity? Molecularity means number of colliding molecules. So here two molecule, like 2A molecule is colliding, so you can say molecularity is 2. Here also 2 molecule is colliding, here also 2. Okay, so molecularity you can say like 2 in these cases, like each step there is 2. Okay, then what is called intermediate? Intermediate means something is formed in one step and consuming in another step. See, if it's so, what's the intermediate here? A and B is reacting and forming X. Okay, is the X is consuming? Yeah, X is consuming here, so you can say X is intermediate. Any other intermediate? Yes, Y is formed here and Y is consuming. So anything is formed and consuming in next step. That is what we called intermediate. Catalyst means it is used in reaction and can be regenerate. Can be what? Regenerate in the reaction. Is there anything? So A and A is reacting. We can't regenerate. A have to produce, right? So there is no A is producing, and X and B reacting. Yeah, there is no B. Y and B is reacting. Yeah, there is no B, which means there it is catalyst is not involved in this reaction. Okay. Yes. Suppose the reaction says like A plus A, some C, some other letter G is there, and then finally we get back to the G, then you can say G is the catalyst. Okay, so that's the meaning. And see the question related to the reaction mechanism. See, they were given some step 1 and step 2. A proposed mechanism of the reaction above, and the rate law is given like this. K rate is equal to K Na to Cl1. Okay, if it's so, the overall reaction known to be exothermic. Which of the following energy profile represent a potential energy pathway for the total reaction? Okay, so what are the important point? The rate law is given. NO2Cl is the reactant raised to 1, and this is exothermic. And see which of the following graph is related to this reaction. So since it's exothermic, you can skip the C and D option, right? Both of them are endothermic. Okay. Then what about A and B? Which one is A and B? How do you know? That's why you can think about, see the reaction once again. What is this? The rate determining step is the slow step. So which is the slow step here? Na to Cl, Na to Cl raised to 1 is the rate law, which means Na to Cl is only the reactor involved, right? So step 1 is the slow step. Okay, step 1 is the slow step, means their activation energy is bigger, right? So see the options here, the activation energy for the first step, step 1 will be the slow step, which means their activation energy is higher. So which is higher activation energy for step 1? Reaction, this A is showing like that. Okay, and also this is, see the, it's kind of Plato, right? That Plato is also indicating the what, intermediate. Okay, some lifetime is there for intermediate, that's why it shows an what, intermediate. And is there any intermediate involved? Maybe. See the first step, Na2Cl plus Cl. See, Cl is formed and Cl is consumed. So Cl is the intermediate. So two things are there. First one, the first step is the slow step idea, and definitely there is an intermediate involved. So this kind of graph will not be there. It should be some lifetime is there for intermediate. Okay. So that's it. And then the next question, as I told you, I will show that kind of high what, hidden idea about like how to find the order of reaction. Okay, you need to find the overall order of reaction. They will give this kind of data, not like a table rate direct equation. Okay, we already shown that A B C concentration, when it doubled, what happened to the rate. That is not, that kind of questions I'm not talking about. This kind of question. Okay, so here how do you find out the rate of equation, like rate law? So as I told you, the most hidden thing is, yes, the half lifetime and the initial concentration relationship. So see here, H2O2 is 8 H2O2 is there, and now it's H2O2 is 4 only, which means half is reacted, and again another half, this is 2, so another half lifetime is done. So see the half lifetime, every time it is found to be 200. This is also 200. So even the initial concentration is reduced, the T half is not changed. It is constant. So that is only possible with a first order reaction. Okay. Yes, that's all about the kinetics. If you have any doubt, just drop a comment below and subscribe for more videos. Thank you for watching. Bye.